How to understand robot kinematics without complex math. Imagine trying to figure out where a robot's hand is without doing any complicated calculations. Sounds tricky, right? But it's actually easier than you think. Let's explore how to grasp robot kinematics in a simple way. First, think of a robot as a chain of connected parts called links. These links are joined by joints that rotate or slide. When a joint moves, it changes the position of the robot's end effector, which is like the robot's hand or tool. To understand how the robot moves, you need to see how these joint movements affect the position of the end effector. Start with the idea of forward kinematics. This is like following a path from the joints to the hand. If you know the angles or positions of each joint, you can figure out where the hand will be. Imagine bending your arm. Moving your shoulder, elbow, and wrist changes where your hand ends up. You can visualize this by imagining each joint as a pivot point that shifts the position of the next segment. Now, inverse kinematics is the opposite. You want your robot's hand to reach a specific spot. The question is, what should each joint do to get the hand there? This part is trickier because multiple joint positions can lead to the same hand position. Sometimes, no solution exists if the target is out of reach. To avoid complex math, use simple tools like drawing diagrams. Picture the robot as a series of straight lines and angles, like a stick figure. Use basic geometry and triangle rules to estimate where the hand will be based on joint angles. For example, if your robot has two segments, you can draw a triangle to see where the end will land. You can also use free software or online simulators. These let you input joint angles and instantly see the position of the robot's end effector. It's like playing with a digital model that responds to your adjustments. This makes understanding movement much easier. Break down the movement into small steps. Change one joint at a time and see how it affects the position. This helps you see the cause and effect relationship clearly. Focus on the workspace, which is the area the robot can reach, and the configuration space, which is all the possible joint positions. Knowing these helps plan how the robot moves efficiently. In real-world applications, understanding how joint movements translate into hand positions helps in programming robots for tasks like picking up objects or assembling parts. Robots with fewer joints are simpler to understand because their movements are less complicated. So, to get a grip on robot kinematics without heavy math, think of the robot as a connected chain of parts. Use basic geometry to relate joint angles to positions. And take advantage of visual tools and small steps to see how each joint affects the overall movement. This approach makes learning robot kinematics straightforward and practical, especially in the fields of robot design and development.